Hi, I'm making this video to show a little physics demonstration that comes out of this book, The Physics of the Violin by Lothar Cremer. In the first chapter, he describes a one-dimensional oscillator that is excited by friction, by stick-slip friction. And he says this is pretty much the simplest way that you can imagine the physics of the violin string being bowed. And there's a great little paragraph where he talks about an idea that came upon him while editing a German standards paper. And he says that he thought of this oscillator that consists of a pendulum sitting on a tiltable turning disc. And the friction between the pendulum weight and the disc will cause this to oscillate. And and that's it. He says that in just a few sentences, and I thought, well, that sounds like a lot of fun. So I built this, and you'll see that I have a little gear motor and battery switch, and this is just my little disc. Here's the weight made of brass, and you can adjust the angles here. So let's give it a try. In the book, he talks about how there will be two sort of regimes of oscillation, two ends of the spectrum. And one will be where the oscillator, where the pendulum spends most of the time free and only gets a little kick every cycle, a little tiny kick from the friction. And then the other one will be where it spends most of the time sticking to the disc and then slides back quickly and gets caught like that. And so we'll see how that works. So the first thing, like I said, we'll have the angle pretty close to horizontal, and we turn it on, and so we turn it on, and we see that the pendulum is oscillating very slightly, but that is a regular oscillation. And we'll see that it spends most of its time just freely oscillating. Now, if we take this and move it so that this is actually tilted much closer to horizontal, we'll see that it'll start to show the other behavior. Sorry, sometimes this needs a little kick. There we go. And stop doing it, but you can kind of see for a second that behavior there. And maybe this isn't working perfectly, but I thought this was a lot of fun. Not a whole lot further you can go. Maybe you could do some calculations, changing materials or angles, friction constants, stuff like that. You could try measuring the frequency at different angles or something. But mostly, I just loved that that Lothar Cremer had put in something so fun and just a little clever thing that he said. And this book is filled with stuff like that. Definitely recommend it. Okay, that's it.